All right, welcome back, students. In this video, we're going to cover the second half of the Module 2 study guide. Just a quick preface to the beginning of this, and I hope you're listening. I said this at the beginning of the last video, but I'm doing last year's review. It has a few extra problems. It's going to have the same, but it's going to have some extra. So, and this is when it'll start splitting apart. I'll try to let you guys know. And the extra problems, and especially if you're listening or watching and you're not in my class, this is more, it's not for a part of the grade, but any extra helps. If you need the extra practice, then please do that. If it's something you're weak at, then it's a good opportunity. So just watch, please. Okay, so left off the last video with number 6. We're going to start with number 7. So, and this, so this is where it splits off. Number 7, for me, this is one you don't have. So let me do this one real quick. Or actually, you do have it, but that's so weird. So this is okay. Yeah, let me look again. We left off with your number 6. This is number 7 for me. It's number 6 on your paper. I don't know. That last one on the other side was extra. That's where the confusion. Okay, sorry. Now, all right, so number 6 for you. This is number 7 on here. Let me just write this because it's not that the paper printed wrong. I just have extra problems. So we've already done an extra one. That's why this is ahead. All right, so number 6 for you guys. Let's do it that way. I'll just do this, yeah. And let me go ahead and look beyond just a moment. Let's see, 9. Yeah, I skipped the problem we added in about the thumbtack and the string, but I'll pull my other notes over here just so you guys can kind of see that. It looks like they sort of asked. Well, anyway. All right, so number 6. Says the 3 interior angles of a triangle have a sum of 180. And this is always true, always, always, always. All right, so if 2 of the 3 angles are complementary, so 2 of 3 complementary, which conclusion is accurate? So before we look over here, so we have 180 total, all right? 2 of 3 are 90. So let's see. So if 2 of the 3 are 90, let's subtract 90 from 180 to see what's left, because that's what the last angle will be. 180 minus 90 equals 90. 90 is what? It's a right angle, which if it has a right angle, it is a right triangle. So that's how you do that. But I skipped past, just assumed that you guys knew that complementary was 90, and that's where I meant to stop, and I apologize. So if you didn't know, there's your freebie. If you did know, then good for you. But so complementary, and I've been saying in class, complementary starts with C, and that's 90. We'll write over here supplementary. All right, so complementary equal the 2 angles equals 90. Supplementary, the 2 angles equal 180. Complementary starts with a C. It's earlier in the alphabet, so 90 is smaller than 180. S is later in the alphabet. That's why 180 is bigger. Hopefully something like that might help you guys. It kind of helps me. All right, rolling down to number 7. And I'm messing with the lighting. I'm hoping this is a little better. And my daughter stole my pen. Okay, well, we'll just do this. All right, number 7. Rhea is using coordinate grid to map out how far she biked from each town. And each town is going to be each point here. Each unit represents 1 kilometer. So what I'm going to do part A. And part A is going to ask you 2 of these sides. Part B is going to ask you for the whole triangle. So I'm going to do the part A, And I'm going to set you up for part B and then move down. Number 9 is one of these. I'm going to put it in a square because it's not on your sheet. You're probably looking like, where's that circle at? Well, it's not there. This is from last year. It's not on the test, but it is a good, it's just good practice. So we're just going to do it. All right. So Ray wants to travel the distance from K to L. So K to L, and then from L, then to M. So L to M. So L to M. So we just put the letters together. We're going to look for KL, and we're going to look for LM. Down here, you guys are going to finish the triangle, and you're going to look for MK. So I'm just going to set this up for you. All right. Okay. So we're going to use the distance formula. I'm going to start out in one color and switch over. So from K to L, I'm going to put this brown. So that's KL. I'm going to write the distance formula over here in red. You guys, hopefully you're carrying your copy of the reference sheet with you. If not, I will gladly give you more. We can have one at home, one at school. Man, you keep one in your backpack. You put one under your pillow. If you heard that and you're paying attention, there's your bonus points. So if you heard me ask you to put it under your pillow, the reference sheet, that is. So distance formula. The square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. All right, so for KL, I'm going to go this way. I'm going to say that L is my x1, y1. K is my x2, y2. Okay? So KL. So I'm not going to rewrite this. I'm going to just start from here. But we're plugging in these numbers. So here so my x2, so x2's first, is 2 minus. Then I'm going to look over here in case it's a negative. All right, because it's minus x sub 1. X sub 1 is minus 1. Minus 1. I'm going to do this until for a little while, and I'm hoping we'll eventually be able to do this a little easier on our own. All right, so that's squared plus. All right, so y sub 2 is 2 minus y sub 1 is 6. So we didn't have to do anything extra there, but I always like to write it. Let's see. We want to keep. Excuse me 1 second. Grab my red colored pencil. Okay, sorry. Try to change colors. So, all right, we're going down. I'm going to try to keep our space, but not make it where you can't see it. I'm trying to, again, I'm working on the lighting so I can, and then we have this kind of problem in the classroom with there we go. That's squared up there. All right, so we're going to bring this down. So 2 minus negative 1, so that minus is a plus, so 2 plus 1 squared plus, and then 2 minus 6 over here, so positive 2 minus 6 is going to be, I put a plus here, it's going to be negative 4 squared. Okay? All right, now I'll go back to brown. So we're gonna combine some of the math here, so because we're running out of space. All right, so 2 plus 1 is 3. 3 times 3 squared is 9. Negative 4 squared, so any number squared is always positive. So negative 4 squared, and I'm going to just prove it to you. So 4. So negative 4 squared, see, it's positive 16. 4 squared, 16. Doesn't matter what number it is. If it's negative, it's squared, because a negative times a negative is a positive. So, so we got 3 squared, which is 9, and then 4 squared, which is 16. All right, so 9 plus 16 is 25. The square root of 25, so for those of you that don't have that memorizing it, and it's fine. I mean, everybody learns different. So 25, then we hit square root. There you go. Square root of 25 is 5. So KL, so from here to here, is 5. Now, pretty sure looking at this, we could measure that out. That's the same. I'm going to do it again just so you see. Okay, we're going to scooch over. We still have our formula. I'm going to kind of draw a line. And then, so over here, and you can do this anyway. If you want to keep these x1, y1, then you can make this x2, y2. Or you could change them, because I'm always telling you guys to work left to right. But just since we've already written this x1, y1, let's just write x2, y2 down here and then plug it in as we see it, okay? So this is LM. All right, LM equals, all right, so our x's, so we got -4 minus, before I even look, -1. -1 squared plus, see, we're kind of running out of room, 2 minus 6 again. So looks, hang on a minute, make sure I did this right. Yeah, it would be -4 minus -1. Yeah, okay, sorry. So yeah, 2 minus 6 over here. Because it was y sub 2 minus y sub 1. 2 minus 6. And I slipped off the paper, but you guys know that that's squared. So let's scooch over since we have a little room. All right, so -4 minus -1, so +1 squared. So you see where this is going. See, -4 and +1 is going to be -3. A negative number is going to be positive. Sorry, I'm writing ahead here. Plus. All right, so this was 2 minus 6, -4. -4 squared is 16. I'm going to kind of, and then, so we got 16 over here. -4 plus 1 was -3. We're going to square that. It's going to be +9. So 9 plus 16 is going to be square root of 25, which the square root of 25 over here was 5. It's the same thing over here. Sorry if I sped that up. I apologize. But it basically, both those are the same. So to get from K to L, so K, L, let's see, plus KM. So it's 5 plus 5. All right, so KL plus KM, 5 plus 5. So our answer up here is 10. All right, so down here, MK, for part B, they want the whole triangle. So you went from here to here. Now you just got to go from here to here. So here, I have these as your x2, x1. Let's make this your x2, y2. Make this your x1, y1. So plug this formula, this formula in here. So you're going to have the 2 points on this side. The 2 points on this side. Go ahead and write that in. If you have, what I like to do, if it's a negative number, I cross it and make it a positive, because that's what happens. But I was trying to show you guys, some of us aren't as comfortable as others, so I'm trying to show it best we can. So anyway, for this one, they'll want the whole thing. So you've already got 10, so it's 10 plus what you find here. So part B equals 10 plus MK. Okay, so find this, add it to 10, and that's your total. So scooching down. Again, number 9 is not on your paper. So find the circumference in the area of the circle. Round it to the nearest hundredth if necessary. So for this, we're going to use the distance formula because we need a radius. So circumference, that's the This is the same as perimeter. And it is on your reference sheet, pi times 2 times pi times the radius, or you can write it that way, same thing. Area is pi r squared. So either way, we need the radius for both of these guys. The radius is CD. So x1, y1, x2, x2, y2. And we will find the distance, and we will use that to find our circumference and our area. And I'll just put CD is radius. And you can tell that goes with this and not the one above. Okay. You don't have to write that. That's just me telling you. All right, so the x's are 6 and 4, so 6 minus 4 squared, plus the y's are 3 minus 8 squared. All right, so 4 minus 6 is 2 squared, plus 3 minus 8 is negative 5. Negative 5 squared, I'm just going to go ahead and do that because it's 25. 2 squared is 4. So 4 plus 25 is 29. Okay, so this was negative 5 squared. I'll just do it that way. Negative 5 squared became 25. This plus this. All right, so now we need this. So we need the square root of 29. Let me just make sure. 29 square root, I don't like that it goes right away, but all right, so that's 5.38. We're going to round that up to 5.4. So now that our radius equals 5.4. So now for circumference, it's 2 times pi times r. So 2 times pi times radius, 5.4. Over here for the area, I'm going to go ahead and write this out. It's the pi times r squared. So it's pi times, excuse me, 5.4 squared. Now, let me go over here. And I've said this in class, and I'm going to say it again here. In geometry, pi, and I know that's not a very good drawing of pi, so we'll say that one. Or, anyway, pi. In this class, unless something says specifically use something else, like if it says use 3.14 for pi, then you most certainly do that. Unless it says something like that, that is pi. You have to, so you hit the button and it gives you all the numbers. So we're going to do it just like that. We're going to just type it in. So 2 times pi times 5.4 equals, so we got 33.92 nearest hundredth. So remember tenths, hundredths, so 0.93. So 33.93. See, it said hundredth. So the circumference, boom. All right, clear it. Now pi times 5.4 squared. Now that's 5.4 squared. So if you wanted to, you could say pi times, now it's 29.16. Then you hit equals, and that's where the area is going to be 91 point. So they want the hundredth, tenth, hundredth. So we want to go 91.61. Okay. All right, moving right along. We're already 19 minutes in, and a lot more to go, I think. All right, number 10 on my paper. And where is this one on yours? Because I know it's there. It's number 8 on your paper. That's right. I got confused because we had so number 8. All right, number 8. It's a bit of a trick question, and I could show you my notes. It says trick question, but so it says triangle ABC has vertices. Let me straighten this up here. Doesn't have to give the coordinates. It's just saying under which transformations is AB equal to A prime B prime. Now remember, we have pre-image is the before. Pre-image, that's the before. We'll just do this. That's A, B, C. And then the image, so it's going to look the same, but we say we move down here. So it's A, B, C. But it's A prime, B prime, C prime. That's the after. A prime, B prime, C prime. So this means, does it change? All this is asking is, does the size change? Because that's the length of one side. So does the size change? All right, so under here, which ones can that happen? Reflection. If we reflect it, well, hold on. So reflection, rotation, translation. So all these are moving. Those are rigid transformations. Rigid transformations. So we learned at the beginning of 2-4 that rigid transformations always maintain the angle measure and the distance or the size. So this one's all of the above, and that's y. Word to the y's. So over here to the side. So remember, the only thing that doesn't change side is dilation, and that's when you go to the eye doctor. Dilation changes size. So dilation changes size. Everything else does not. Okay. Let's flip down. All right, number 11. Line segment AB is rotated about the origin. If the coordinates for A and B are 0, 0, and 13, 0 respectively, which of the following could not be B? Okay, so a couple of things we need to talk about before we go any further. So if we had the graph paper, sorry, my drink has got my pencil wet. If we had the graph paper, so 0, 0, that's the origin. 13, that's the X. It's going to go right 13, but it's not going up and down. So these two, if you counted, it would be 13 apart. Okay? So the distance of AB is 13. So we just talked about up here that only dilation changes sides. So when it moves, it stays the same. So if this is, so AB equals 13, and A, it rotates about the origin, so A stays the same. So your A for all of these would be 0, 0, okay? So this would be your A, this would be your B. It's asking which one of these, so which one of these does not equal 13, okay? Now, remember that, I'll try not to confuse you guys too bad, but I'm going to try to show you a little shortcut. So bear with me a moment. So our formula, the distance formula. Oh, I'm looking in the wrong spot. Sorry. The distance formula is x sub 2 minus x sub 1 plus y sub 2 minus y sub 1. All right, so these would be your x1, y1 is 0, okay? So this is all you have left on both sides. It would be 0 minus 6 for the x's and 0 minus 7, or 0 plus 6, 0 minus 7. Remember the signs, but they're going to be squared, so it doesn't really matter. Just let me try to do this up here and help it make sense. So if my x2, so we'll do it for the first one here, all right? So this would be all over here is your x2, y2. So these are the only numbers we're going to plug in. Remember, these are zeros. So x sub 2 is negative 6, and then my y sub 2 is positive 7. All right, just bear with me. We're going to do it one time up here. So again, remember, this is 0 and this is 0. So minus 0, minus 0. So negative 6 minus 0 still just leaves negative 6, and we're going to square it. Negative 6 squared is positive 36. 7 minus 0 is 7. 7 squared is 49. All right, so that equals 85. Now remember, that's the square. We need whatever it is. We need the square root. Remember, these we square both of these, and all right. So the square root of 85 is 9.2. So already, and this I could tell you this is the answer, but I want you to see why, because this one equaled, so 9.2. That was your, and 9.2 does not equal 13, right? So remember, all we ended up with was the two numbers. So we squared the two numbers and added them together. So just watch, we're going to do it all on the calculator. So 0 squared is 0. 13 squared is 169. And now we need the square root of it, remember, because we're taking the square root. That's 13. So this one, 0 and 13 equaled 13. You square 13, you get 169, and you take the square root. 13 does equal 13, so this one couldn't have been, it says which cannot be B, okay? Now here, 5 squared is 25. 12 squared, I should have done this over here. So 5 squared, let me just let you see the buttons. I want y'all to see everything. 5 squared plus, it's negative 12. Remember, negative or a positive squared is still a positive number. So add them together, you get 169. Take the square root, 13. So so it ended up being 25 plus 144, which is 169. And then you take the square root of that, and it's 13. So this one couldn't be that. And then down here, so we got 12 and 5. So 12 is 144, and 5 is 25. That's still 169, which is still 13. So I'll just show you again. So 12. So again, let's just say this is we'll say 5 minus 0. So we're doing this. Is 5. 5 squared is 25. Okay. 12 minus 0 is 12. 12 squared is 144. Plus the 25 from the 5, 169, take the square root, it's 13. So all three of these equaled 13, but this guy equaled 9.2 because it was 36 plus 49. Let me write that a little. 49, because it was 7 squared, which is 49, and 6 squared, which is 36. All right, scooching down. I'm going to try to hurry a little bit about the lighting and such. Sorry. All right. Number 12. Scholar claims that rigid transformations were used to map AB to A prime B prime. Is Scholar correct? All right. So you're going to use the distance formula. And I'm not going to do this one all the way through because I've given you several examples of the distance formula, but I'll show you how to do this. So we want to see if AB equals A prime B prime. So AB, let's call these your, so X1, Y1, X2, Y2, and then down here X1, Y1 that's supposed to be A prime, and then X2, Y2 for B prime. See, B prime, A prime, B prime. So you're going to find the distance for AB, and you're going to find the distance for A prime, B prime. God, I wrote that wrong, idiot. Oh, let's just do it this way. So A prime, B prime, D equals, and then AB, D equals. So find these and then see if they equal or not. If they do, it's yes, and then look at these questions or look at the rest of it and see which one matches. If it's no, it's one of these two, and it should be that they either equal and it's one of these two, or they don't and it's one of these two. This is it's less this number is less than this number, and this number is bigger than this number. So see what you can do with that one. All right, number 13. So it's kind of a two-part question. So we'll notice here at the top. All right, so Darren's baking a 2-layer cake. So you're gonna have 2 of these guys, and they're in the shape of a cylinder. So we'll just say cylinder A, cylinder B, but let's see, the bottom layer is 6, so we'll call cylinder A the top, cylinder B the bottom. Oh Lord, I'm writing all this and you guys, I'm way off the page. My bad. So what I'm going to do is show you guys, I'm going to do A, and you'll see you do B. Now the total, so your answer here is going to be the total, which is cylinder A. I'll just say A plus B. So over here I'm cylinder A. Now for the cylinder, and this is on your reference sheet, if you do not have it, I have mine. And for a cylinder. Now, let's read the rest of the problem. I got ahead of myself. All right, so we're baking a 2-layer cake. So we have 2 cylinder pans. The radius for the pan on the bottom. So we'll just say radius A is 6 inches. Radius B is 4 inches. And then the depth of the pan is 2 inches. Now, you're like, well, where's depth? Well, it's going to be height in this case, because the depth of that pan, you set the pan down and it's this deep. Well, that space that we fill the pan up is how tall it is. So tall and height. So your height is 2 inches. So height for both. So not just one side. All right, so our volume for cylinder. So I'm going to do a couple of things. So volume for a cylinder is base area times height, okay? Now this B, so the base is a circle on a cylinder, right? And the base area for a circle, so base area for a circle is pi r squared, okay? So B equals pi r squared. So I'm going to replace this B with that pi r squared. So the volume is going to equal pi times the radius squared, so we have a radius, times the height. So you're just going to plug and go. Let me scooch all this over. And then to get the final answer, you're going to take my total plus the total you're going to get over here, because we're going to do the same thing over here. Just do this. You're going to go B equals, and I'll go ahead and write out the formula for you. So it's pi times the radius squared times the height. So over here, mine is pi times the radius squared times the height. Pi. So my radius for A is 6. And the height for both of those is 2. So I'm going to do all the math. I'm going to let the calculator, but I want you to see how to do this. All right, so we're going to type it in just like this, except we're going to hit, it's multiplied. It's multiplied. So we're going to go pi. See how it typed out the number. Times 6 squared times 2 equals. So 226 point, it says to the nearest cubic inch. So 226 is what we're going to do. We're not going to round up. We're going to leave it round down. So we're going to say 226. All right, so for A is 226. So your total. So now you do the same thing. The only difference here is the radius for B is 4. So get that out, get your total. Now scooch down the page so I can finish this up. Number 14 on here. What is it for you guys? Give me a moment, because I didn't even... The 2-layer cake thing. Good God, did I ever tell you what number it was? Well, no. And it's number 11. So, this one's number 11. This one's number 12. This one is not on your on your deal, and then this is 13. So yeah, almost done. This one had roast beef. This little piggy had none. Okay. All right, so surface area of a solid shown. So this is a prism, and its volume is blank cubic inches. So volume is the easy one. I'm going to write it over here again. So volume for a prism is base area times height. Now, for this rectangle, that base area is length times width. This is how long it is, this is how wide it is, and this is how tall it is, because it's sitting on its base. And this base would be length times width. So to get all the volume, you're just going to multiply all three of those numbers. So your length times your width times your height, or 10 times 8 times 6. Where's my calculator? 10 times 8 times 6. 480. So volume is 480. Say 480, okay. And surface area. Prism. Handy dandy deal here. My reference sheet. Cylinder and prism. All right, so this has two bases. See, the one on the top, one on the bottom. So surface area is going to be 2 times the base. Then we need to go all the way around it. So that's the perimeter times the height. So our base area, we already had that over here. It was 10 times 8, length times width, right? So B is 8 length times width, or 10 times 8. Which one? Either way, 10 times 8 is 80. So I'm just going to build my problem here. 2 times the base area was down here. It was 80 plus. All right, so perimeter. Remember this rectangle. So if this side is 8, this other side we can't see, it's 8. This side's 10. This side over here is 10. So your perimeter, we're really in the bad light now. Hold on. So your perimeter is length plus width plus length plus width. So it's going to be 8 plus 10 plus 8 plus 10. So that's 16 plus 16. That's 32. I know I did that kind of fast, but 8. So 10 plus 8, or 8 plus 10 plus 8 plus 10 to get 32. So there's your perimeter. And then the height was right here. It's still the same. It's 6. So bear with me a moment. All right, so 2 times the base area, which was 80. Trying to figure out the light here. If I do this. I already got that off. Maybe that's even better. Maybe that's even worse. It's like I get better and worse. Okay. All right, so 2 times 80 plus, so there's your 160, 32 times 6. Let's see, hold on, 32 times 6. Oh yeah, it did it, but it didn't give me that second number, 192. And we add those together. It's 352, I think is what it was. Yeah. This is 352 square inches, because remember, area is squared, just like, and this is, but perimeter is linear, so it's just inches, and then over here it's cubic. So 352, 480, and what did I do? That's 36, yeah. There's my mistake. 36. Sorry. And this is 160 and 260. I knew something didn't sound right. I'm sorry. 216. And this is 376. I apologize, guys. I knew something didn't feel right. And that's what happens when it's late and I'm not looking at my notes. All right. Down we go. One more on this this side, again, this is not, I'm just boxing this in because this is not on your sheet. But it is something we're going to practice. So, volume for a regular pyramid. I want the volume for this. That formula on my reference sheet that I always have handy with me is 1/3 times the base area times the height. All right, so this dotted line, because it's dotted line and it's perpendicular with the ground, I know that's the height, like if it was on standing on, if that was going straight through it. So this is your height. Now, this is I said square, it's rectangular because you see it's not completely equal. So if this is 12, over here's 12. This is 10, over here's 10. Well, we don't need perimeter, but still good to know. So the base area for this is length times width. All right, so 12 times 10, which is 120. So we have 1/3 of 120, and the height is 10. So multiply these two, and it's going to be 1/3 of 1200. But let me just so you guys know. So 120 times 10. So we're at 1200. Now you can multiply by 1 divided by 3, but I always like to just, since we can divide the whole thing by 3. So your volume would be 400. And this will be cubic units cubed. Yeah, cubic units. Cubic units cubed. Okay. All right, last one. Number 13 on your page. Oops. Okay, so the shape of the water tower can be partially modeled as a sphere, by a sphere, in which the diameter is 28. Painter needs to calculate the surface area of this part of the water tower to accurately estimate the amount of paint needed for the job. What is the surface area of the portion of the water tower needed the nearest foot? So we have this water tower that goes up, and it's a big ball on the end, and they need to know how much for that ball. Now, let's think back. So let's think back here. So diameter. And let's do this. So we're going back here. Diameter, this is a line that goes all the way through the circle. Radius is the half one. They gave us the diameter we need, so surface area for a sphere, let me write this over here because I have my reference sheet. It's 4 times pi times the radius squared. All right, so if the diameter is 28 and the radius is half of that, so radius is half of 28, which is 14. So 4 times, and that's one of the tricks there. You guys have to see that it was the diameter and remember that you need the radius. Let's see, so 14 squared is 196. So that times 4 is 784 times pi. And they wanted the nearest whole number, which is going to be 2463 feet square. All right, guys, that concludes Module 2's review. If you have any questions, let me know. Until next time, have a great night.